in this video, we're going to put all the information, all the lessons that we've learned about transformations, and we're going to put it all together. All right, so let me just get right to it and with an example. So let's say, for example, I have some function, and I call that, let me just put this in white. So let's say I call it y equals f of x, and I transform it to y equals 2 f of 2 minus 1/3 x, and then I put plus 1. So this is my function. I'm transferring from f of x to this thing right here. So remember, step number 1 is really to factor what's inside of the f. So I put 2 f of, and when you're factoring, factor out the coefficient of x. So the coefficient of x in this case is negative 1/3. So it's negative 1/3. If I factor that out, it's x minus 6, right, plus 1. Why is it minus 6? Well, negative 1/3 times x is negative 1/3 x, and negative 1/3 times negative 6 is positive 2. So that's how you do it. So now let's basically write the list of transformations, right? So since there's no negative, remember, it's always reflection, stretch, translate, and it has to go in that order. I have to keep insisting that. So first, is there a reflection in the x-axis? No. So there's no reflection over the x-axis. In fact, you don't even need to write this statement, but I just wanted to highlight that. Because there's a negative on the inside, there's definitely a reflection over the y-axis. All right. Let's see if there are any stretches. Well, this is 2, so it's a stretch in the y direction. We know it's y because it's outside of the f. In the y direction by 2. Now I should really write by a factor of 2, but because I'm just out of space, I'm simply going to write 2. But you should really write by a factor of 2. Then let's look at this 1/3. Well, and so we would say a stretch in the x direction by 3. Why is it 3? Because remember, we take the reciprocal of what's inside. So the reciprocal of 1/3 is 3/1, or 3. And by the way, we don't say that this is negative 3. Even though this is negative, it's taken care of by that reflection. This negative means reflection. So since we've already discussed the reflection, we do not need to put negative 3. And in fact, a negative 3 for a stretch doesn't make sense. Like, how can a stretch be negative? It really makes no sense. Let's 2 more things. We can see it's a translation. Oops, let me just write that. So let me just scroll back up just a little bit. Here we go. So we can see it's a translation to the right. Translation right by 6 units. We know it's right because when it's negative on the inside, it just means to the right. And finally, it's a translation up by 1 unit. By 1 unit. All right, so let's say, for example, I take this very same function and I apply it to the one that we've been using throughout. So in other words, that f of x function. Once again, the edge points for this function are 1, 2, 2, 4, and 4, 1. So once again, I'm going to go from y equals f of x to, sorry, what was it? 2 f of, and I'm just going to write the factored version over here. So the factored version was negative 1/3 x minus 6 plus 1. So if this is our original, so the question then becomes, what will the new transform function look like? So let's start step by step. So let's go through the previous, and this is the exact same function, by the way. So there's no reflection over the x-axis. And remember, that affects the y's. So our y's will remain positive. So I'm just going to write positive over there. So we've taken care of that. There's a reflection over the y-axis, which means it affects the x values. So there's definitely going to be a negative right there. So we've taken care of that. Then there's a stretch in the y direction by a factor of 2. So that means our y values will be increased by 2. And there's a stretch in the x direction. I'm going to take care of that. There's a stretch in the x direction by 3. So that's going to be 3x over there and 2y over here. Then it says translation right by 6 units. So that's going to affect the x's. So it's going to be a plus 6. And finally, there's going to be a, oops, let me scroll down a little bit. There's going to be a translation up by 1 unit. So what that means is this is going to be plus 1. Now, basically now we just have to write what the new coordinates will be. So this 1, negative 3 times 1 is negative 3 plus 6. So that's going to be negative 3 plus 6. So that's simply going to be 3. I've done this before, and you can do the calculations by yourself. So this is 3, 0, negative 6. Just to see how that 4 works. 4 times negative 3 is negative 12. Negative 12 plus 6 is negative 6. And then you can do the same things here. So let me just do the first one as an example. 2 times 2, that's 4. 4 plus 1, that's 5. And then this is going to be 9, and that's going to be 3. So let's plot these points. So our first point is 3, 5. So 3, 5. So that would be right here. Our second point is 0, 9. So here's 0, 9. That's right there. And our final point is negative 6, 3. So negative 6, and I would say 3 is somewhere about here. So negative 6, 3. And now let's just connect the dots. Let's do that there. Okay. So let's connect this with that right there, and connect that with right there. So basically, this function right here is this big one right here. Is it's 2 f of negative 1/3 x minus 6 plus 1. You can kind of see that it's sort of stretched. So this vertical stretch of 2. So you can kind of see that it's stretched up by 2. And then remember, this 1/3, we take the reciprocal, which means the horizontal stretch by 3. And it clearly definitely looks like it's stretched in the x direction by 3 times its original amount. And this negative here means that there's a reflection across the y-axis. And it does look like, if you observe, it looks like sort of a reflection across the y-axis. And the negative 6, in other words, 6 to the right and 1 up, that's a little bit harder to see, per se. So if you've done your calculations right, this should be correct. But it's sort of overshadowed by the effect of the stretches and the reflections. So this is a little bit harder to see, but definitely we know that it's sort of in the right direction, and the stretch, both stretches in the vertical and x directions are correct. So that's our first of 2 examples for putting everything together. I'll see you in the next video.